I want to make a presentation today about the X-ramp configuration versus diamonds. This is a topic that's been active in many states that use frontage roads for some time. And here in Texas, it's been an active conversion. Even here in College Station, we've actively been converting between these two configurations from diamonds to the X-ramp configuration. And there have been some questions about, it clearly has some operational benefits, but what does it have in the overall safety perspective? So that was kind of what drove the decision to take a look at this project. I will say that this is actually a Texas DOT funded project from the San Antonio district. And they were very specific that they didn't want to just study San Antonio, they wanted to study the state of Texas. So it's a Texas-based study, but supported from San Antonio. We are still underway for the second phase of the project. So basically what I want to do is just give you a quick overview of what the objective of the project is, what our phase one activities are, they're just about completed, and then what the phase two activities will be. So the objective, kind of historically, they've been having issues with when they convert from the diamond interchange to the X-ramp configuration. The frontage road has for many years been in place with the driveways in their locations, their current locations. And when they change the location of the on-ramps and off-ramps, there's been pushback from the community about the driveway location and whether or not they have to keep those driveways at the same place or what justification you have for asking me to move your driveway. So that was really the underlying purpose of this particular study, was to try and get a good sense of, does it matter where the driveways are in relationship to the on-ramps and off-ramp configurations for both the diamond and the X-ramp configuration. You'll note the phase one is focusing on the frontage road. So our phase two, which is just now starting, is focusing on the adjacent freeway. So we'll have the full picture. So I'm only showing you the first part of the picture, which is the frontage road instead of the adjacent freeway. So many of you probably know this by heart, but just to give you a quick overview for those of you who this is familiar with, this is our traditional diamond ramp configuration. And on this traditional diamond ramp configuration, you'll typically have a vehicle that's going onto the freeway, and you might have vehicles that are coming off of the freeway. And our concern is that we have this weave or merge, depending upon the ramp configuration, up on the freeway. And what are the safety implications of this particular issue? And so in converting from from diamonds to X-ramps, we take this weave and we shift it away from the freeway. So for X-ramps, the off-ramp is immediately after the interchange, and then there's an on-ramp before the next interchange. And so here you'll have basically the on-ramp, the activity between the two maneuvers is going to be located on the frontage road instead of the freeway. So clear operational benefits there. But what does this do for safety? Well, you'll notice that this particular area tends to be longer. This potential weave area on the frontage road tends to be a little bit longer. You have driveways that were at one point not exposed at all to this traffic, and now they're going to be fully exposed to this traffic, and cars might be trying to get across into those driveways, or people might be coming out of those driveways and thinking, cool, I can get across real quick now and get up on the freeway, even though it was never intended for that to happen. And so all of those are the issues that we were trying to get a good handle on when we were doing this study. Now here was our problem. There is no wonderful database in the state of Texas that tells us where all these interchanges are, or intersections for that matter. There are some jurisdictions that have that information, but holistically there's not one database available. So we had to do a little GIS manipulation before we could identify some candidate locations, because our goal was to randomly select sites. And in order to randomly select sites, we have to have the sites to select from, obviously. So what we did is we first used GIS, and we intersected the freeways with roads that were categorized as arterials. This would give us, we were hoping, the center line points for freeway to arterial locations. We also took a look at locations where we had turnarounds, because that gives you extra points that identify a few more locations. And then we tried to focus in and study each one of these sites individually. One of the other things we wanted to make sure happened is there are, of course, a lot more interchanges in the populated areas. So we wanted to make sure that we studied the entire state of Texas. I personally grew up in West Texas, Big Spring, Texas. I don't hear any whoops on that. What's going on? And we don't have too many, well, we have dirt roads out there, but we have a few interchanges, but not too many. And we want to make sure that we had some representation across the state in locations where they did actually have interchanges. And so we actually extended this sampling to be a stratified random sample to capture geographic locations as well. So ultimately what we did is we ended up collecting 93 randomly selected locations. Of those, 62 happened to be X-ramps, 31 were traditional sites. A little imbalanced, and so we went and collected some more traditional sites. We have about 30 more that we're currently downloading the data for, and they'll be included in the Phase 2 activity. And we looked at, for those sites, we looked at the frontage road configuration. We focused on urban corridors because this is where this conversion has been occurring primarily. And we looked at where the driveways were located in proximity to the physical nose of the gore, upstream and downstream, what kind of characteristics we had at those locations. One of the other things we noticed, of course, is that no interchange is treated equally. Most interchanges are not treated equally, so we want to try and limit the number of variations that we had. So we only selected segments that had an interchange that was a diamond, and then the ramps, in the case of the X-ramp, the off-ramp, and then an on-ramp, and then the next interchange. Or in the case of the diamond, the interchange, then the on-ramp, and then the off-ramp. So the whole idea was to try and have some consistency between them. And then we pulled data from Rhino. We confirmed data from Street View. One of my colleagues, who I think I saw walk in a minute ago, Mike Pratt, built this really cool tool to help us use that data real efficiently and download this information straight into a spreadsheet tool. Thank you, Mike. And then we assembled crash information for each side. Each side would be the segment between the two intersections for the frontage road. We also went in and used Google Earth tools to try and peg all the driveway locations that we could. That was where this macro came in that Mike wrote. And we looked at driveway density as well as proximity to the nose, the front, the nose, the front of the nose of the gore, physical nose, the painted nose, and the back of the gore. And then we also identified where the centerline intersection of the upstream and downstream interchange would be, because that would define our limits of our study area. One of the other things that is always an issue when you're looking at crash data, if you have a major interchange or intersection included in that, is that there's a lot of crashes and have nothing to do with what you're studying. They're all affiliated with the interchange or intersection. And so we screened out crashes that were intersection-related crashes within 250 feet of the upstream and downstream interchanges. When we randomly sampled sites, we sampled looking for this, what we call a central intersection, and then we looked upstream and downstream of that particular location. And as long as it met our conditions, we tried to include it in the study. This is just basically showing how we put pins to get the gore. So all of this was very useful in trying to get both lateral as well as longitudinal location information. This is where we actually use the gore itself. And then we try to determine what would be some logical variables to collect. So we went back to this little schematic I showed you a minute ago, the influence of the traditional ramps or the diamond ramps. And here, when you have the on-ramp, you have the potential for having vehicles interacting and potentially even weaving on the frontage road from the interchange, the downstream interchange, I'll call that interchange number 1, up to the first on-ramp, which I'm going to call gore number 1. And then similarly, at the off-ramp, you have the reverse. But you do have this large region that's not really directly affected by the behavior onto and off of the freeway, which is an optimal location to be putting driveways. So you can imagine years ago when these were built and they were diamond configurations, that was the focus location to put the driveways. So now many of these locations have driveways there, and we're trying to convert them into a configuration that's going to do almost the opposite. For the X-ramps, now we have a region that's essentially not affected upstream and to some extent downstream of the weave. But we have, however long this section between our two gores are, is essentially a long weave section. And so you can see how driveways can have an adverse effect there. You also, of course, have concerns about the number of lanes because that can exacerbate the weaving configuration. So kind of a summary, what we did is we collected almost every piece of data we could think would possibly be a contributing factor. We have many of these that turned out to not be significant. But we specifically looked at things like the ramp type, the segment length, the distance between the gore noses. We created this new one called gore ratio. This was particularly important on the X-ramp configuration, which was the gore distance divided by the segment length. It gave us an idea about, for that entire segment length, about how much of that is in fact going to be occupied by the gore. Total segment driveways, and then the number of driveways within the limits of the gore, which we define that as 400 feet upstream and downstream of the physical nose of the gore. We also counted the access density along the road, as well as within the gore. Looked at distances from the noses to all sorts of characteristics, the number of lanes, and the traffic volume. One of the things that, of course, is a challenge if you've worked with the CRIS crash data is that frontage road crashes are mapped to the center line of the freeway. That's just a given. We knew that was going to be an issue. So we had to start with that. Then we had to go in and take a look at the characteristics of the crashes themselves. In a few cases, we couldn't determine which frontage road they were on, but most of the time, you could tell by, if you had two vehicles and they were both in the same direction of travel, you could probably assume that was the frontage road that was applicable to it. So we didn't know where on the frontage road laterally it was located, but we were able to at least extract information from that to try and determine if it was a frontage road related crash. We also looked at data for 3 years, 5 years, and 7 years historic crash data. When we picked our sites, I had a graduate student who got the thrilling activity of going back to every site and looking at the historic characteristics to see when the ramp conversion occurred. Because if the ramp conversion occurred 4 years ago, we had to take it out of the 5-year study. So we had to go through that, and so ultimately we just ended up using the 3-year study or the 3 years for the primary study, because as you will, if you've been driving around much, you'll have noticed there's a lot of these conversions that have been going on. And so it really eliminated a lot of potential crashes, or sites and their crashes. And then we merged all this data together to do statistical analysis. So for the fatal plus injury crashes, we modeled both fatal plus injury as well as total crashes. But for fatal plus injury crashes, for the X-ramp configuration, the variables that were critical were this gore ratio thing that we came up with. By the way, the reason we came up with the gore ratio is because segment length and gore length both ended up being critical values, and so they were confounding each other. So in the statistical terms, if we could make that into one variable, we could remove some of that problem. The number of driveways in the gore area, the upstream distance from the nose of the gore to the closest driveway, and then the number of lanes that you're shifting just downstream of the gore. So those are the key things that were critical for fatal plus injury crashes. When we looked at the total crashes, that they're the exact same items for the X-ramp, but they had one additional item, which was the downstream distance from the nose of the gore, which is the second gore, to the closest downstream driveway. So proximity to upstream and downstream driveways was obviously a critical factor. Now, I know everyone loves to see equations, and so I've shown you the equations, but really I did this so you can see the variables themselves, just so you can kind of get a snapshot. But this is basically what the equations look like. They're pretty user-friendly, as long as you have a spreadsheet tool. But this is the spreadsheet tool, and I've even been told do a spreadsheet tool and then also make a little cool graphics so that we don't have to use your spreadsheet tool. I don't know what to make of that, but I'm going to do it. The cool graphics, I mean, somewhere along the way. But this is just the equation for that as well as the total ramps. And as you can see, those are basically the characteristics that I was referring to. We had cool names, like I called DUP G1, which is really downstream, or distance upstream from Gore 1, but I think DUP G1 sounded a whole lot funner. So sometimes you have to be a little creative when you're doing these. So a review from findings, we also looked at the traditional, or the diamond ramp configuration. We did the exact same analysis for both. And there were only two variables that were really critical for the traditional diamond, and that was the number of driveways in the Gore region. That's not a surprise at all. And the prevailing number of lanes between Gore 1 and Gore 2, the potential where you might have some sort of maneuvers. But we also, just as a reminder, removed the first 250 feet of intersection-related crashes from both upstream and downstream because we assumed that those were mapped to the interchange. And so when you do that, there is a chance that some of these ramps, which were very close to the interchanges, those intersection-related crashes could have been driveway-related crashes. So we just kind of took that with a grain of salt, recognizing that could be a limitation to that particular approach. So we're adding these additional 30 sites to this, and we're going to try and see if we can refine this a little bit better. And then these are the two equations again. So one of the things that immediately came to my mind is, so what's this tell me? Does the X-ramp have more crashes or less crashes than the traditional diamond? I already know it has operational benefits. And I suspect when I do the phase 2 safety analysis, it for sure is going to have safety benefits. It just makes sense when you pull a weave off there that you're going to have fewer crashes. So we just went through the equations and tried to see what happened if we did an example problem. So I used the exact same example problem. I used a gore ratio of 30%. This was actually the average gore ratio for all of our sites. I looked at the number of driveways in the gore region, the distance upstream and downstream, and the number of lanes. And I found that if you calculated the fatal plus injury crashes, just for this one example problem, that says you have about 6 crashes for a 3-year period, or 2 crashes per year. On the flip side, if you did the total crashes, that gives you about 24 crashes. This is segment to segment, not including the 250 feet either side of the intersections. And that would be about 8 crashes per year. As an alternative, as a reminder, there are really 2 critical variables for the traditional diamond, the number of driveways in the gore region and the number of lanes, number of lanes at the gore. And if I use the same approach, I calculated that comes out to be 4 crashes in 3 years, which is about 1.3 crashes per year, or 19 in 3 years, which is about 6.3. So if you compare them together, you can see that they're pretty close. The traditional diamond interchange is slightly outperforming, with the analysis we have at this point. However, I will point out that I always round crash numbers up to the nearest whole number, especially if I'm going to talk to the public. Never tell the public you're going to have 1.3 crashes. They don't like that. So when you do round it up, you'll see that for the fatal and injury crashes, they're actually fairly similar. And then for the total predicted crashes, also not too different. It'll be interesting to see what our phase 2 tells us about that. So some additional observations. There were 2 variables that always were critical for both the X-ramps as well as the diamond traditional configurations. One was the driveways in the gore region, the number of driveways in the gore region, 400 feet upstream and downstream. So that tells you if you can avoid putting driveways 400 feet upstream or downstream of any of these gores, no matter which ramp configuration you have. And the same thing with the number of lanes. The larger number of lanes, the larger number of crashes, which would make some sense. The only other thing I don't want or I guess I want to leave you with without diminishing this research is that this is only phase 1, and I know that there's going to be some trade-offs when we do phase 2. So if I were to walk out here today, I might walk out saying, well, obviously the X-ramp has some safety issues that the traditional ramp doesn't, which I don't actually think is too obvious. I don't think that they're actually that different. But when I add the number of crashes that we're going to have on the freeway, I think that what we're going to find is the X-ramp is going to outperform the traditional diamond. So just keep that in mind, that this is a work in progress, and that when we do that second phase, I'd be very surprised if that doesn't happen to be the case. So phase 2 activities, we're going to assess the safety effects on the freeway segments adjacent to these locations. We're going to add in those 30 locations I mentioned earlier to try and balance out our analysis. We're going to develop the self-calculating spreadsheet for the Texas DOT to use. And then we're going to assemble these user-friendly cool charts that will probably usurp the use of the spreadsheet, but will give you the opportunity to very quickly determine what issues you might have in the placement of your driveways in these particular ramp configurations. So that kind of is, in a nutshell, the study that we're working on. I'd be happy. Do we want to take questions?
Yes.
If you have any. Yes.
Yeah, I saw from the exhibit that you showed, converting from a diamond interchange to an X-ramp, actually you're changing the weaving section from the freeway part to the frontage road. The HCS or HCM has the methodology to analyze the weaving section on freeway, but do you know if there's any methodology to analyze the weaving on frontage road?
I don't know. Oh, go ahead.
I have to repeat that question because we have to say it into this so it's recorded.
Okay.
There's a method to analyze weaving section on the freeway, and you're wondering if she knows a method to analyze the weaving section on the frontage road.
Correct.
That's your question,
Yes.
right? Okay.
So I don't know if there's a method that specifically addresses that. The work that was in the Highway Capacity Manual was done by a gentleman named DeFazio. and he had some boundary limits that were upper, and that might actually apply better to frontage roads than they do to freeways. We do have a graduate student who's working on a dissertation right now with me, and she's actually looking at, if you come off of the intersection and you turn right and go towards the next closest major intersection, what that weaving looks like. And our expectation is when we finish that weaving effort, we might be able to translate that down to this. But right now, I don't know of anything that gives you that direct answer.
Just a quick question. I know you consider the driveway density as one of the important factors. And do you differentiate like driveways, because of residential driveways and commercial driveways?
Okay.
Okay, the question is if that driveway density was considered in the analysis, but if there was a distinction between residential driveways and commercial driveways.
So we used urban locations in the state of Texas. We did actually do an inspection to see what type of driveways they were, and almost without any exceptions, they were all commercial driveways. There are occasionally a really low volume driveway that might, there might be some sort of a residential component, but it was very insignificant. All of these, it's just the nature of the frontage road on these particular examples.
Just one more question, please.
During emergency crashes on the highways, a lot of times the frontage roads are used as detours because of the benefit of the ramp location. Is that considered in the study?
Your question was during the emergencies, the
Between the overpasses, there's a lot of crashes in the expressway itself or the main lane. And there's a benefit added to the X-ramp configuration that they can be detoured and go around the emergency zone or the crash zone.
okay.
Utilize the frontage road.
Okay, is that a statement or a question? What he's saying basically is that there's a benefit to the X ramp configuration based on the fact that if we have an emergency, you can detour traffic around, get them down, and then get them back up. Is that not what you're saying? You're asking if it was considered in the study as part of an emergency management strategy, isn't it? Okay.
So the focus of phase one was the frontage road in the configuration with the driveways. The focus of phase two will be the freeway, adjacent freeway configuration and the safety effects. We haven't explicitly noted that one as something we were going to be looking for. I know that when Texas started making the conversions from diamonds to X ramps, there were two very detailed studies that were performed actually at TTI, and they addressed many of these issues. And so we don't want to be redundant on something that was done before. So I'm going to take a look at those and see if that issue has been covered adequately, and so stay tuned. I wish I had a better answer for you, but that's probably phase two.
One last question. You had a question, sir?
The crashes that you have observed in your database and the time of the crash, does it have an effect on the volume that is present on the highway? Because those things are interrelated, and that captures the content.
Okay, he's asking if consideration was taken as to the time of the crash and the volume on the highway.
So we don't have information about the volume at the time of the crash. That's just not something that's readily available. We did include ADT to try and determine if the traffic volume, the prevailing traffic volume on a daily basis was characteristic that would be statistically significant. It was not. That actually alarmed me because I expected it to fully expected it to be. So I went back and looked at it, and the reason is because there's not a lot of variability in our ADT for these particular frontage roads. So once you have a variable that's consistent from site to site to site, you just don't see that happening. That's one of the reasons, in particular for the diamond, that I'm increasing the sample size, is I wanted to take a second look at that particularly for those. So I think it's simply because the locations where we've elected to make this conversion are already high volume frontage roads that have fairly consistent levels.